To homebrew a ladder line. We know that the loss per meter of ladder line is much less than a coaxial cable. Ladder line is a balanced feed line while coaxial cable is an unbalanced feed line. But the impedance of a ladder line will be much higher than that of a usual coaxial cable, which is 50 ohms typically. So we'll have to use a matching transformer or antenna tuner while using a ladder line. So you can see these two are parallel wires, and I am going to use 2 inches pieces of this drip irrigation tube. Drip irrigation 6 mm tube. These tubes are UV protected so they can bear sunlight. And I will be using this nylon ties for holding these together. Let us see. It is quite easy to cut this soft drip irrigation pipes using a simple scissors, and I have cut a few pieces of 2 inches each, and this is how the ladder line construction proceeds. Even though I have kept these pieces near each other, we need to have the steps of the ladder line only about 20 centimeters apart. One end of the nylon tie is introduced through the pipe, that is drip irrigation pipe, piece of drip irrigation pipe. The other end is folded back as a loop, and through that you include the wire as well, so that one side of the ladder is secured. Tighten one end of the loop. And the other end of the nylon tie is introduced through the slot at the end of the nylon tie for tightening. It's done, make sure that the second wire goes through a loop. Now the loop has been tightened and the nylon tie has been locked. So this is the first step of the ladder. Similarly, you can continue making steps at 20 centimeter intervals throughout the length of the feed line which you need. I'll be doing that tomorrow because I don't have so much length of wire. This is just a demo, and this method was told to me by VU29 Alfa Romeo, formerly VU3 TPW. You can see that now one more step of the ladder has been made. Even though I am demonstrating this on a bench, the best way to make this is to tie both ends of the wires between two supports firmly and stretch the wires properly so that this will be equal on both sides and the wires will be straight. And keep on tying like this till you reach from one end to the other end. That is how it has to be made. Yesterday I saw a nice discussion by Steve WA5FRF in the Ham Radio Science Citizen Investigation Ham Sci Google group. I am summarizing it here for the benefit of those who are not members of the Google group. As you can see in the picture, open parallel wire transmission line is often called a ladder line. It has two bare wires held at exactly the same distance apart by insulating spacers which could be made of plastic. Advantage mentioned is that by using a minimum amount of dielectric insulating material, attenuation or power loss per meter is less than the usual coaxial cable. As a comparison, which Steve has mentioned, if the loss in coax is 2 dB, corresponding loss in a ladder line may be just 0.2 dB. If insulated wire is used, relative permeability of the insulation will alter the characteristic impedance of the ladder line. Other factors which affect the characteristic impedance are the ratio of the wire spacing to wire diameter and conductive loss in the rung insulators. Typical impedance, though taken as 450 ohms, could vary and may even be 600 ohms, requiring an antenna tuner for matching. Steve mentions that when you use resonant HF dipole antennas at modest height having impedance near 50 ohms, there is no point in using a ladder line if you are operating on resonant frequency and its third harmonic. That is exactly what I am doing, operating on 40 meter, 15 meter and 10 meter with an inverted V fan dipole for 40, 10 meter. I am using RG213 coax with 50 ohms impedance and a 1:1 current balance at the feed point. As he mentioned, the balance strips off currents on the outside of the shield and avoids the problems of a radiating hot feed line which could occur if balance was not there. If I were to use a ladder line, I will need an external antenna tuner to match the near 450 ohms impedance to the 50 ohms of my radio. But things are different if I want to use the dipole on non-resonant bands. An external antenna tuner will be needed for matching the impedance on non-resonant bands. It is in that situation that the open wire or ladder line has advantage as it has lower losses. Ladder line does not obviate the need for a tuner but reduces the total losses during multiple back and forth reflections from the antenna to the radio in the transmission line. Whenever there is a mismatch in the feed line, part of the power is reflected back from the antenna as measured by the standing wave ratio or SWR. Reflected power when it reaches the tuner is sent back to the antenna once again. As the process repeats, transmission losses are converted to heat energy and could cause burning off the coax at higher transmitted powers. This possibility is also minimized by a low loss ladder line. In short, advantage of ladder line is when you are trying to match non-resonant antennas to your radio with an external antenna tuner which can cater to higher SWR like 10:1. There is less loss of RF energy as heat and improved efficiency of transmission. As a tailpiece, Steve mentions that correctly designed center-fed dipoles on fundamental and odd harmonics, some off-center-fed dipoles, and many trap dipoles can give matches on multiple frequencies that are good enough to operate with coax and a tuner without a lot of line loss. But if the antenna cannot give a low feed point impedance on all desired frequencies and needs more aggressive tuning, then the ladder line provides a far more efficient solution.